In this lesson, we'll set a design's structural constraints. After completing this lesson, you'll be able to demonstrate how to set a structural constraint and understand the options when setting a fixed constraint. Let's carry on with the file from our previous example, and let's talk about setting up our structural constraints. For this design, we have relatively little interface with the environment. We have two mounting plates, and we're going to assume that those are fixed to some sort of mass. We're going to be lifting this device with 1,000 pounds of force. So then we really need to control how it is interacting or held into the rest of the device. So what we're going to do is we're going to figure out how we can make the plates on the end fixed and talk about a few different ways. So first we want to go to our design conditions and select structural constraints. Under the type we have a few options. We have fixed, we have pin, and we have frictionless. In this instance, we're going to be using the fixed constraint. We can select the targets, and then we can select the axes in which we want to control. For this device, we're going to assume that this plate cannot move at all in the Z direction. So it's physically pushed up against something in the Z direction, and the same thing for the opposite side. So with those two fixed in the Z direction, we're going to say OK, and we've added the first structural constraint. Now, thinking about this in terms of the overall design, if we're looking at how we can hold this inside of our coordinate system, inside of X, Y, and Z, we've only told it that it can't move in the Z direction. This still allows it to move up and down in Y and left and right in X, so we need to control those motions as well. So under design conditions, we're going to go again to our structural constraints, and again we're going to use fixed, but this time we're going to be focusing on the X and Y direction, and we're going to be using the bolt holes as the locators for this. We could also simply fix the bolt holes in all three axes, but again, if we're looking at this from a realistic perspective, the bolts are going to be pressing the plates against the wall. And since we're not analyzing the stress on the plates themselves, what we're doing is we're just telling it how it interfaces with the environment. So I'm using the location of those holes to control the X and the Y, and then I'm using the back faces of the plate to control the Z. And again, we could very easily have just done X, Y, and Z on the faces of the back plate or on the bolt hole locations, and in this instance we would have gotten a similar result. So keep that in mind, that when we start to define these things, that there could be multiple ways to look at it, and we should really have a good understanding of the physical interaction between our devices. From here, let's make sure we navigate back to a home view and save our file before moving on to the next step.